for this, all you have to do is we're going to find the characteristics of a polynomial here. And it's nice on this polynomial because the polynomials are already written in factored form for us. And what I mean by that is you can actually see all the factors of f of x is equal to x minus 2 squared times x plus 3 times x minus 1. Each one of these is a different factor, and because you have your factors there, they're going to be solutions. So to start this, they ask, well, using the leading coefficient. Leading coefficient means when this is written in standard form, which means that I have a ax to the n plus bx to the n minus 1, where all of these values are just decreasing exponents. What is my largest exponent going to be? That's called the degree. And from this, I can see because I have two solutions here, one solution here and one solution there. If I add the number of solutions, there's 4 total solutions. So my degree here will be 4. And the other thing, because there are no negatives sitting in front of any of these parentheses, I know my a has to be positive. And you're interested actually in whether a is positive or negative, and the degree, whether it's even or odd. You're in whether it's even or odd. And we can make a chart out of this. And on that chart, here's what we have. We have the n value, which n can be either odd or even. And we have the a value, which a can be either positive or negative. And if a is positive, if a is a positive odd, so positive odd, we get basically the line for an odd function. And that line starts down right here, and it finishes up here. So it's a down-up graph. And if a is negative, it just flips the line like this. So again, the graph starts up now and finishes down, so we get a up-down graph. That's what the tails are doing. That's what you're interested in. Every graph that's odd looks like this. Every graph that's even, positive evens are a parabola. And notice here that when it's a positive even, it starts up and it also finishes up. And when it's a negative even, it just flips the graph like this. So when it starts down, it finishes down. So when I look at this, then I'm analyzing this function and trying to figure out which one it matches to. Well, because this is a no negative sitting in front of parentheses, is a positive a is positive, and your n here is equal to 4. So this is a positive even. Positive even is here, so that means it's an up graph. So it looks like D is going to be the answer there. We check that. That is the right answer. So let's go to the next part. Find the x-intercepts. If I want to find the x-intercepts in factored form, all you have to do is change the sign on these values here. And those are all your x-intercepts. Your x-intercepts are where the y value. So we literally set this equal to 0 and solve it. Well, when you do that, you're just going to change your solutions there. So your x-intercepts, x's are equal to -2 changes to +2. And this tells me that I have 2 of those. So this has a multiplicity. We call it a multiplicity. That means it's repeating twice. It's a multiplicity. A multiplicity of 2. Then we have +3 becomes -3 when you solve it, and -1 becomes +1. So your 3 solutions are +2, -3, and +1. I think I typed those in there right. Let's try it again. So we did -2, +3, +2, -3, and +1. Struggling to type these in. Hold on one second. Let me get these typed in. There we go. Type those in. So I get +2, -3, and 1. Check those there. And so the next part says the graph crosses the x-axis at the zeros. And here's how this works. Depending on what your solutions are, if your solutions come with multiplicities are going to touch the graph and turn, while answers that are unique or only show up one time, they go through the graph and turn. So when we graph this, this is a rough sketch, but using those x-intercepts, we have the values of -2, -3, 1, and 2. And we know the end behavior says it starts up and it finishes up. And because negative 3 only shows up once, the graph is going to come through negative 3 like this, come over here to negative, up to the next intercept, which is 1. It's going to go through 1 because 1 only comes up once, and it's going to keep turning. But when it gets to 2, it's going to touch 2 and come back up without going through. So the graph is turning, and it goes through negative 3. So it goes through negative 3, and it also goes through positive 1. And the graph is touching. The graph touches the x-axis at 2 because 2 is a multiplicity. So we're going to touch at 2 and turn. So depending on if it's multiplicity or not, multiplicity means it's repeat. If you see exponents above your solutions like this in factored form, it's repeating. That's multiplicities. That means you touch and turn. If nothing's there, that means it's a unique solution. That means you go through and turn. And then the next part says find the y-intercept. Well, to find the y-intercept, if we want to find the y-intercept of any one of these type of problems, all we have to do is let the x value be 0. So you evaluate f of 0. So we're evaluating 0 minus 2 squared times 0 plus 3 times 0 minus 1. Well, 0 minus 2 squared is just negative 4 squared, or negative 2 squared, which is just 4, times 0 plus 3 is 3, times 0 0 minus 1 is negative 1. So that's equal to negative 12. So the y-intercept here is just negative 12. And the last part says determine whether the graph has y-axis symmetry, origin symmetry, or neither. And because we have a couple points that we can choose from, and I'm just going to pick the I'm going to pick one of these x-intercepts. I'm going to pick this negative 3, 0. Well, if it has y-axis symmetry, then if negative 3, 0 is on the graph, y-axis symmetry would suggest that if you change the sign of the x value, because you're going across the y-axis over here, that means that the point 3, 0 should be on the graph, right? And then if we can see that 3, 0 is not going to be on this graph, so it doesn't have y-axis symmetry. If it had x-axis symmetry, or if it had origin symmetry, then the point negative 3, 0 flips completely and becomes 0, negative 3. You change the points around. XY becomes YX in an origin symmetry. So you're looking for the point 0, negative 3. And because 0, negative 3 is not on this graph, again, we don't have that. So this is going to be neither. And as a matter of fact, most of these graphs will be neither. Check that. And we get neither. And that's how you solve this problem. Hope this helps.